Today we're going to be introduced to Chapter 4, Lesson 4, Linear Functions. What will we learn today? To represent a function by writing an equation, completing a table, and graphing the function on the coordinate plane. So three different things: writing an equation, completing a table, and graphing the function on the coordinate plane. Graph a function. Here we have y is equal to 5 minus 3x. So sometimes functions are written using two variables. You can see we have two variables here, the y and the x. One variable, usually x, will represent the domain or the input. The other, usually y, represents the range, or also known as the output. When a function is written in this form that we see here, it is called an equation. Like equations, functions can be represented in words, in a table, with a graph, and as ordered pairs. The graph of a function is the set of ordered pairs consisting of an input and an output. So our first example is a real-world example. The school store sells book covers for $2 each and notebooks for $1. Tony has $5 to spend. The function y equals 5 minus 2x represents the number of book covers, x. So book covers is going to be my x. And notebooks, y. Notebooks is the y she can buy. Graph the function. So they want us to graph that function. That's the first thing. And then interpret the points graphed. Second thing we're doing. So our step one, choose values for x and substitute them in the function for y. So very similar to what we were doing yesterday. You get to choose any values. I would choose these four values. Now we're using positive values because obviously you can't buy negative books or notebooks, book covers or notebooks. So for x, we're using 0, 1, 2, and 3. And they gave us our function rule, y equals 5 minus 2x. So then we plug in the 0 for each of the, for the first x. So that gets plugged in there. For the second input, plug in there, 2, and then 3. And we end up with 4 outputs. Remember, our y is our output. So we have 5, 3, 1, and -1 as our outputs. So our step 2, now we can get ordered pairs from our graph. We have 0, 5 is our first pair, 1, 3, 2, 1, and 3, -1. So to graph these ordered pairs, here's what the graph looks like. 0, 5 up here at the top. Then we go 1, 3, 2, 1, and then 3, -1. Now, obviously, like I mentioned, she cannot buy negative amounts, so she can buy 0 covers and 5 notebooks. That's this one here. Or she can buy 1 cover and 3 notebooks, or 2 covers and 1 notebook. So there's 3 possibilities. Again, the 3, -1 would not work out. Example number 2, we are graphing functions. So we're going to graph y is equal to x plus 2. So once again, we're going to make a function table. That's our first step. Our function table has our input, or our x, which is also our domain. It has, so let me put input. We have our rule. The rule comes from the function. And then we have our output. And we have another column over here for our ordered pairs. Remember, to graph any function, you're going to need ordered pairs. So substitute the values for x to find the value of y. So you can see 0, sorry, wrong way. 0 is substituted for x there, 1 for x there, 2 for 2 there, and 3 goes to replace that x. And you can see all the y values. And we wrote the corresponding ordered pairs. Step 2, graph each ordered pair. And you're going to draw a line that passes through each point. We're doing a line for this graph because we don't know what this represents. If it's a function with no representation, we don't know if it's a real world problem or not. Right now, it's just a function. We need to go ahead and do the line to represent all the points that work. So here's what the graph looks like. There's our first point, 0, 2, second point, 1, 3, third point, 2, 4, and lastly, 3, 5. And again, draw the line because all those points along that line will make this function work. Brief stop for representing functions, our key concept. So in words, the value of y is 1 less than the corresponding value of x. So this is the way functions can be represented in words. This word problem can be represented in an equation, y equals x minus 1. And we can have ordered pairs from the table, and then we graph them. So there's 5 different ways to look at a function. So on this screen, you can see there's a lot of information, but please bear with me. It's just 3 definitions and some very important information. So don't skip through this. A linear function is a function in which the graph of the solutions forms a straight line. Therefore, it's called a linear function, just like a linear equation that we talked about earlier in the year. Therefore, an equation in the form y equals mx plus b is a linear function. A function can be considered continuous or discrete. Continuous data can take on any value, so there is no space between data values for the given domain. So a continuous data can be like the problem example number 2 that we just did. Discrete data have space between possible data values. Discrete data graph will look like example 1 in this lesson. Graphs of continuous data are represented by solid lines, and graphs of discrete data are represented by dots. So a couple of examples for continuous data graphs: the number of ounces in a glass. Okay, that can be continuous. You can have 1 ounce, 1.5 ounces, 1 3/4 ounces, all the way to infinity if you have a big glass. The weight of each chocolate chip. Now weight again can be fractions. It can be whole numbers, but it can also be fractions. Discrete data, the number of glasses in a cupboard. You cannot have half a glass. You have to have full glasses. So it's going to be each dot on the discrete data graph is going to represent 1 glass. The number of chocolate chips in a bag. Okay. Most chocolate chips in a bag are going to be complete. So you can cut it into half, but that's not what we're talking about here. It's discrete data, the full or whole chocolate chip. So let's look at another real world problem. Okay. Each person that enters a store receives a coupon for $5 off his or her entire purchase. Okay. Rarely happens, but it does exist. So for example 3, write a function to represent the total value of the coupons given out. So let y represent the total value of the coupons and x represent the number of people. So the function is going to be y equals 5x. Okay. The y again represents the total value. $5 is our 5, and then x is representing the number of people that it's given out to. We're going to make a function table to find the total value of the coupons given out to 5, 10, 15, and 20 customers. Now in this case, we don't get to choose which values. They're giving us the 4 values, 5, 10, 15, and 20. So we put in our inputs, 5, 10, 15, 20. Our rule of 5 times x, we substitute for x. 5 times 5 is 25. 5 times 10, 50. 5 times 15, 75. 20 times 5 is 100. Graph the function. Is the function continuous or discrete? And then explain. So this is what the graph would look like. This is 0.525. Now again, this represents that For 5 people, the value that they've given away is $25. A business would need to know this information to see how much money they actually gave away. Second point is 10 people, $50. And then the next one is 15 people or customers and $75 given away. And then finally 20 customers and $100 given away. So we graph the order pairs. Now you can only have a whole number of customers. So the points are not connected, and because they're not connected, this function is discrete. Do not connect the dots in this, like I mentioned before. You cannot have a half a customer. Now you can have 6 customers, you can have 7 customers, but you cannot have half a customer.